Right, welcome back to Genius. So let's continue with advanced JavaScript. So we'll be talking about closures. We'll talk about higher order functions. So we'll be understanding what closures are and higher order functions. All right. So we talk about closures. We talk about higher order functions, and you're to read. You don't know JavaScript. Read Scope and Closures, chapter 1 to 2. You guys should make sure you're reading this book, so you should make sure you're reading it. Okay. I can only tell you. I can't tell you everything here, but the book would expand your knowledge, make you understand better. Okay. So your task is the problem statement is that write a program that creates a counter function using closures and higher order functions. All right. So you should write a function that creates a counter function, a program that creates a counter function using closures and higher order functions. The counter should start from 0, then increase by one each time the counter is called. Don't worry, you're going to learn how to do this. Basically, that's what we'll be doing in this class. And then you also provide two additional functions. The one that increases the counter by 1, and another one decrement that decreases the counter by 1. Okay. So we are creating your task is to create a function that um, a counter function that increases by 1 each time the counter is called. And then you should also create another function that decreases the counter by 1 and another one that increments the counter by 1. Okay. So you would also create another additional function that gets the value, it returns the current counter value. So increment function, decrement function, and get the value function. The get the value function will return the current counter value. It's going to be spicy. This is going to juggle it's going to really make you juggle your head, and you're going to think out of the box doing this. Okay. So make sure you understand what I'm going to teach in this class. Let's dive in. So what are closures? A closure is a function that remembers the environment in which it was created, even after the environment no longer exists. A function that remembers the environment. So this environment has to do with the scope. All right, when we talk about environment, we're talking about the executing environment. So it has to do with the scope in which it was created, even after that environment no longer exists. In other words, a closure allows an inner function to access variables from its outer function scope, even after the outer function has finished executing. Long story cut short, a closure is like a function inside of another function, an inner function inside of an outer function. So let me show you something. Okay, so I'll create a file. I'll call it closure.js. So a closure is actually a function. I'll call this one outer function. This outer function would contain another function called inner, and this inner function can do anything. All right. So this inner function is actually in a closure. It's a closure because remember that whatever variables we have in here, let's assume that we have let counter equal to 0. All right. This inner function will definitely have access to everything in its parents and scope. So this inner function will have access to anything that is inside of this scope at large. So this inner function would remember this variable. So this inner function is a closure because it is a function that will remember the environment that it was created in. So the environment it was created in is just this scope, even after the outer environment does not exist anymore. So if I go ahead and do something like this, okay, let me assume that I'll be returning this inner function. Let me assume that I'll be returning this inner, sorry, not the counter. I will return inner. Okay, so I am returning this inner as a function, so I'm returning it. So if I go ahead now and say const, and I'll call it inner is equal to, all right, this if I call the outer function is actually going to return this inner function. So basically, the return type, this one I'm studying in this variable is actually going to be a function. So if I go ahead now and say console.log, and I will say I am an inner function. So look at what is happening here. This outer function is a function that returns something. And what is it returning? It's returning another function. And this function is inside of it. So it's running this function. So if I call this function now, what will be returned is a function. So that means I can call whatever that is being returned there. I can say inner, and I put this and I call it. So if I save this file now, and open a terminal, and I say node closure. You see, look at what is happening here. This outer function returns something, which is another function, and this function I can call it. Do you understand? And it says I am an inner function. So this function is being called. So I can even do something like this. I can even say outer, all right? So this would return the inner function. So I can even call it immediately. So if you understand JavaScript so far, all we have been teaching, you're supposed to get this. This will return something. So JavaScript would evaluate this function call, and this function call returns a function. And then the next parenthesis is actually calling the whatever this other one returns. So this will be evaluated first, which returns a function, and this function will not be called. So if I run this, it will still work the same way. I want you guys to really understand these things, okay? Please, if you don't understand what I just did now, please come to the WhatsApp group and then drop a question. Okay, so now we said that closures are inner functions or functions that actually remember the environment even after they have been, even after their environment doesn't exist anymore. So if I go back to what I used to have, I'll say const inner is equal to this. All right. After this function has been called, it's no longer in existence. But the thing is that this guy that is being returned, this inner function, still remembers the environment that it was created in. The outer function will run, all right, it's out of the execution. But the thing is that this inner function would always remember anything that is inside of the environment. So in this case, this counter, all right? So if we say that this, what this guy does is to, first of all, it would increment the counter and then console.log it. Look at what will happen. Look at what is going to happen. If I call the inner function the first time, I call it again, it's going to, we started at 0, right? So the first time I call this inner function, it will increment the counter by 1. Then I call it the second time, it will also increment it. So let me run the code first so that you will see. I will save. You can see 1 and 2. You see, even after this environment has been created and is out of execution after calling this function, the inner function still remembers this counter that started with 0. So if you call this function 10 times, this counter will be incremented 10 times because the environment is still being remembered by the inner function. So this is a closure. Now, it is, see, the first time I saw this closure thing, I ran away. Okay, but I didn't have anybody to explain it to me like this, but try to grab it, all right? If you don't grab it the first time, no problem. Take the video again, watch the video again, retake the class. All right. So you can see now that this inner function was able to remember the environment, and any variable, all right, that is inside of this environment, the inner function would have access to it, and they will always remember it. So it says a closure allows an inner function to access variables from its outer function scope. That's what we just did. The inner function had access to the counter variable even after the outer function has finished executing. So when we call the outer function, the inner function still remembered. So a closure is created when a function is defined inside another function. So how do you create a closure? When you define a function inside of another function. And you saw that our inner function was created. Let me show you. Our inner function was created inside of this outer function. So the inner function accesses variables from the outer function. That's what it did here. The inner function, I had access to this counter variable that we had here and can work with it. So the inner function closes over the variables in the outer function, in the outer scope, hence the name closure. So the inner function closes because it has access to these variables. It closes. It closes everything within this environment. It will have access to anything inside the scope of the outer function. So it closes it. Closures allow data privacy, like private variables in object-oriented programming. You get to learn object-oriented programming in JavaScript later. Okay. They are widely used in callbacks, event handlers, and functional programming. So closure is something you need to learn. So I've already shown you what a closure can really do. Okay, I've really shown you what a closure can really do. So now, in this case, the inner function is returning the counter. It's not consoling it. So I cannot, it's possible that I can return it. So if I go ahead to change the code, instead of consoling it, I'm going to return it. I'll return the counter after incrementing it. But the thing now is that since this guy returns something, I will have to say const. I can say counter 1 is equal to now this. I can say counter 2. I can say const counter 2 is equal to inner. So you can go ahead and as you're doing this, if I say run this code, okay, I'm not consoling. Now I can say console.log the counters. I can say counter 1, counter 2. So if I save it and run it, you see I get 1 and 2. So in this case, the inner function is returning something, and the outer function is returning the inner function. So if I call the outer function, it returns the inner function. And since once this has been called and the inner function is here, the inner function would have access to the any variable that is inside of here. And since we incremented it, it will always be incremented and it keeps going. All right. So if I call the outer function, it returns the inner function. And then if I call the inner function, anytime I call the inner function here, it keeps increasing the number. So even though the outer function has finished executing, in this case, the outer function has finished executing, the inner function still remembers the counter. That's the closure. All right, the counter variable here, all right, the inner function still remembers it. So it's still within the execution of the inner function. Say, guys, you just have to be very serious with this. I'm telling you. All right. A lot of people will say there is nothing else in tech, that there are no opportunities in tech. Now, people will not sabi anything. You don't know shit. That's why you're saying what you're saying. If you're good at this, you don't even need a job. By the grace of God, I don't need a job. I have created a job for other people. Okay. By the grace of God, I know enough to create a platform to teach. And by the grace of God, you can see how big the platform is growing. So don't listen to people who say that they don't know anything. The tech industry is growing. It keep growing big. All right. So that one is aside. So why are closures useful? Data encapsulation, it keeps variables hidden from outside. So you can see that this counter will only be available to the inner functions. So I can now look at it. If I want to, I can say, okay, I can write another function. Let me give you an expo to your assignment. I can write another function. I will say this function, hey, I'm about to give an expo here, is called increment. Okay. Okay, so I can change this function to be increment. I can call it increment. All right, it adds by 1. I can call this one decrement. Okay, but you now have to figure out the get value yourself. Okay, so when I do this, I can say counter minus minus, then I will return the counter. Yeah. And then instead of returning just one single value, what am I going to do? I'm going to return an object. I will return an object, and then this object will return the increment and the decrement. So now I'm going to refactor my code. So I have the outer function. Okay, it has increment function and decrement function. Okay, so now, and I'm returning an object. So this will no longer be, this is going to be an object. Okay, so I'm going to the structure. I don't think I have done the structuring here in 100 days back. I think it is in the 100 days front end that I've done the structuring. But let me also do it anyway. I will do increments and decrements. Sorry if you don't understand what I'm doing here. Okay, but okay, let me just remove it. This is going to return the object, so I can just call it I can call it funcs, but this funcs is an object. So this object, all right, I can say const, I can say increment is equal to what's it called again? I will say funcs dot increment, okay, and then I will say const decrement is equal to funcs dot decrement, and then I can now say I can call the increment. I can call the increment multiple times so that it will increment the value. Okay, I'll do it 3 times. Then the next time I will do decrement. Decrement. So I might call the decrement 2 times. So let's see if our code works. Okay, so what I'm going to do is that, okay, so instead of returning the value, okay, I will not return the value. I will just console.log it. I want to give you more work to do. I don't want to give you all expo all the way. I want to give you more work. So you're going to write the get value now. I will not do I will just do console.log. Oops. Oh God, sorry. So I do this. All right. So now look at what we are doing. We have the outer value, outer function that has the increment function that increments the counter. The decrement function decrements the counter. Then we are returning an object because we cannot just return one, and we can return 2 values. JavaScript does not allow you to return 2 values, but if something like Go programming language, you can return 2 values. So for me to return 2 values, I can put them in an object to return a single value. Then the single value object will now contain them as variables, okay? So what am I doing? First of all, I will call the outer function that returns the object. So these functions contain the increment and the decrement functions, and I will extract them and then call them. So if I run this code now, fingers crossed, I hope we get it. All right, you can see that 1, 2, 3, 2, 1. Do you understand? So the increment did it 3 times, incremented it 3 times. Look at, we called it 3 times. So it will be 1, 2, 3. And the decrement started from, since the current value is 3, it will decrement it. it will reduce it by 1, then printed the current value 2, reduce it again by 1, printed the current value 1. So this is closure. I'm just loving this class, I'm telling you. All right. So data encapsulation. So what was I saying? What brought me here is that it is only these functions that can have access to the counter. You see, this counter variable now, it is only this function that can have access to the counter variable. Anything outside of this function cannot have access to it. Okay. So data encapsulation, stateful functions, functions that can remember past interactions. All right. Callbacks, they are used in event listeners. Then function factories, they used to generate customized functions. So I hope you enjoy what we have talked about closures, okay? So what are higher order functions? Higher order functions are functions that either takes one or more functions as arguments. So any function that takes another function as argument is a higher order function, or returns a function as its result. So a higher order function can either take functions as an argument or return a function as its result. So in this case, the first time we did returning a function, all right, here we are returning an object. So the outer is no longer a higher order function. But had it been we are just returning one of these functions, we'll call it it will be a higher order function. But right now it's not returning an object, it's returning an object, it's not returning a function. Okay. So functions are treated as first-class citizens in JavaScript and Python. This means functions can be stored in variables, passed as arguments, and returned from other functions. So higher order functions allow abstractions, reusability, and modularity. Example in JavaScript, the map function, the filter function, the reduce function, the find function, most of the functions in JavaScript array, they are higher order functions. So why? Because they take functions as arguments. Now let me show you. If I have an array, guys, I think I will just have to delete everything. So let's say I have an array, 1, 2, 3, 4, 5. So I can say array dot map. You see, this map function expects another function as an argument. So I can either pass in an arrow function. This is an arrow function, or I can pass in an anonymous function, a function without a name. All right. Or I can have another function. I can have another function, a named function, and then I can pass it here. So the thing is that this map function expects a function. So it is a higher order function. Any function that expects another function as an argument is a higher order function. Any function that returns a function is also a higher order function. So map, filter, reduce, they all, even in Python too. I don't know you. Okay. So examples in function passed as an argument. Okay. This function is a greet function, and it takes now this is a normal function, the greet function, and then we have another higher order function that takes a function as an argument. So you can now call this higher order function and pass in the function. So let me show you. So let's assume I have a function called greet. Okay, what does it do? Okay, this greet can just say console.log greetings. All right. Then I have another function. I can call it higher order function. So it will take a callback. So this callback, okay, what am I going to do? I'm just going to call it as a function. So what does it mean? This higher order function expects a function as an argument. So if I go on now and say higher order function, if I call it, I will have to pass in the greet function as an argument. And if I run this code, guess what? It would call the callback function. So what happens? As soon as I call this function and passing another function to it, it will come in here and call it. All right. So when you call this callback function is actually the greet method, the greet function I passed in here, and this will be called. So that is how it works. Okay. So let me even show you. Let me debug. Okay. So to show you that this callback function is actually the greet, so I'm going to put what's it called again? A breakpoint here, and then I'm going to run. I'll start debugging. Okay. Now okay. So you can see it has stopped here. So this function was called, and then when it got inside here, this one was called. So I will now click on, is it step into or step over? I will click on step into. Then you see this, look at now, this callback function here is what is going into here, and this is what is being called. And then if I step over, it has done it, and it's called, the greeting has been consoled. And that could be it. That's the end of it. Do you understand? So you can see that the greet is a function, and I passed it as an argument to this higher order function, and inside here it was called. I think this is very simple to understand. So a function can also return another function. You have seen me do that already when we are talking about closure. I returned another function. Okay. So you can practice that. We have built-in higher order functions. We have the map function, we have the filter function in arrays, we have the reduce function in arrays. What is the relationship between closures and higher order functions? Closures often appear inside higher order functions because when a higher order function is returning a function, the returned function is a closure in higher order function. Example, when a higher order function returns a function, the return function usually forms a closure over the outer variables. Okay, so something like you have already seen this. I think I have done a good job explaining this, but in case you don't understand it, please reach out to me. Okay. All right. All right. All right. So you create a counter. Create counter is a higher order function. It returns another function. That means the return function is a closure. Okay, the return function is a closure, and it remembers the count. Okay. So in real life, closures, private variables like counters, timers, catch, they are remembered. Event handlers, this is where you use them. Function factories, higher order functions, you use them for array transformations, asynchronous operations, and stuff like that. So in summary, function closure is function plus its lexical scope. So the scope of its parent or outer function. Higher order function takes a function as an argument or returns a function as a return value. Together, they enable powerful abstraction, stateful behavior, and then functional programming. Thank you very much, ladies and gentlemen, and I will see you in the next class.